Hi everyone. So today I thought that we could talk about disorders of sexual development a bit by going through a flowchart about how sexual differentiation happens. So I think by kind of understanding this flowchart, it'll be easier to think about how a child would present if certain genes or hormones or enzymes were missing. So I've drawn it out here, so I figured we could just start at the top. So from an embryological standpoint, let's start with intermediate mesoderm. And so then through the expression of WT1, SF1, and LIM1 genes, that intermediate mesoderm turns into a bipotential gonad or an indifferent gonad. So this means that the gonad could turn into a testicle or an ovary. So if the fetus is XY, then there'll be the Y chromosome. And on the Y chromosome is a gene called SRY. And it's this SRY product that makes the bipotential gonad turn into a testicle. So then from here, the testis has Sertoli cells that will express the SOX9 gene that make Müllerian inhibiting substance. And that Müllerian inhibiting substance will cause regression of the Müllerian ducts. So the Müllerian ducts are what would eventually turn into a female internal genitalia, because the female pathway is the default pathway. So a fetus will default to female genitalia unless the Y chromosome and this SARI gene are expressed. So through that Müllerian inhibiting substance, the Müllerian duct regresses. Additionally, the testicle has Leydig cells, and Leydig cells make testosterone. So the testosterone binds to androgen receptor, and this promotes the development of the Wolffian duct. And the Wolffian duct turns into the ductus deferens, the epididymis, and seminal vesicles. The testosterone attaching to the androgen receptor also promotes spermatogenesis as well. Importantly, the testosterone turns into a DHT through the presence of this enzyme 5-alpha reductase. So 5-alpha reductase needs to be there in order for testosterone to turn into DHT. Similar to testosterone, DHT will bind to an androgen receptor, and through DHT binding to an androgen receptor, that is how the prostate, scrotum, penis, and secondary sex characteristics come about. So on the other side of the coin, if the fetus is XX, then there will be no Müllerian, there won't be the SARI gene. So there won't be any Müllerian inhibiting substance or any testosterone. Therefore, the Müllerian duct will develop because there's no MIS to tell it not to. And then that will turn the Müllerian duct, turns into the fallopian tubes, uterus, cervix, and upper 1/3 of the vagina. And the Wolffian duct will regress because there's no testosterone to bind to androgen receptors to tell the Wolffian duct to develop. So this side is pretty passive. This side just kind of happens. Again, like the Müllerian duct will passively form and the Wolffian duct will regress, at least as far as we're concerned. So you can see kind of on this side, there's many spots where things could go awry and then lead to disorders of sexual development. So like with 5-alpha reductase deficiency, there's no 5-alpha reductase, and therefore the testosterone doesn't convert to DHT, and that's why individuals who have 5-alpha reductase syndrome have ambiguous genitalia because the prostate, scrotum, and penis aren't developing correctly, or aren't developing as they would as if there was DHT there. So I was kind of thinking to myself, well, then what about like XX? Sorry, I'm bad at this. What about XX individuals? You know, what do DSDs for them look like? And then I was reminded, like with congenital adrenal hyperplasias, so like the gene CYP2A1, CYP12A, one of those, that's responsible for helping substances in the adrenal gland turn into cortisol and aldosterone. But if that gene isn't working right, then the substances that would turn into cortisol and aldosterone they build up in the adrenal glands, and then they turn into androgens. So if you have an XX individual and they have a buildup of androgens, well, those androgens are testosterone and DHT. So then that's how you would get virilization of an XX individual. So anyways, I hope this makes sense. I hope this flowchart makes sense. And again, I think if we can especially think about the why side of things, all the factors that play into that, then we can noodle out, okay, well, if there's like, you know, a mutation with MIS, what does that mean, and what would we see? So anyways, I hope this helps, and good luck studying.